All right, thank you. Yeah, so my name is Abigail Renegar. I'm a research scientist with the National Coral Reef Institute at Nova Southeastern University in Fort Lauderdale, Florida. I am the director of the Marine Toxicology Laboratory at NSU, and the research program there is broadly focused on understanding the different impacts of a broad array of environmental contaminants on corals and coral reef associated organisms. But for the past few years, the bulk of the research in my lab has considered the impacts of petroleum hydrocarbons to corals, with the goal of providing the right sort of data to improve spill response decision making in coral reef environments, shallow water coastal environments. So to that end, we've looked at constituent hydrocarbons, we've looked at the effects of oils, we've looked at the effects of dispersed oils and dispersant. And now we've been able to look at the impacts of the herder, ThickSlick 6535, as another tool in that oil spill response toolbox in shallow water tropical environments. So we routinely work with about 6 species in the Tox lab. For these exposures, we chose 2 of the ones that occur in the shallowest water. Prides divericata, the thin finger coral, occurs in very, very shallow water, anywhere from 1 to about 3 meters depth. You can find this coral in certain areas in less than ½ meter depth. You can find it in seagrass flats, near mangroves. So definitely a species that's highly likely to be exposed to anything that's sprayed on the surface. The other species is Acroporis cervicornis, which is the Atlantic staghorn coral. One of 2 acroporid species. It also occurs in quite shallow water, a little bit deeper than divericata. This is one of 2 acroporid species and one of several other Atlantic coral species that are listed as endangered under the Endangered Species Act in the United States. So this has some implications for how it's treated from a regulatory perspective. So these exposures are conducted as 96-hour daily renewals. So we have the treatments would include a seawater control, 5 different concentrations of ThickSlick, 6 replicates, experimental replicates per test concentration, and 2 corals per replicate. So the way this is made is we add ThickSlick to 1.5 liters of water, homogenize that mixture, then turn the stirring speed down, allow it to settle a bit, and then we add the corals, and the test solution is replaced every day. So how do we assess the corals during the exposure, during that 96 hours? So of course we look at mortality to generate acute thresholds like LC50s. We've done a lot with, so corals are a non-standard test organism, so we've done a lot to develop test procedures to look at impacts on corals. So in addition to mortality, we also look at physical changes in the coral condition. So we look at sort of common coral stress responses like polyp retraction, mucus production, changes in coloration, i.e. bleaching, also any tissue swelling or tissue thinning, which you can occasionally see. And we monitor these during the entire exposure, over time during the exposure, to get an idea of any time-dependent effects. We also look at photosynthetic efficiency. Now, when you look at a coral, you're sort of generally seeing 3 different things. You're seeing the structure, that is the calcium carbonate skeleton that the coral forms, the thin layer of tissue. Over that skeleton is the coral animal itself. And the corals contain within their tissues a single-cell dinoflagellate, zooxanthellae. And the corals in the zooxanthellae have a symbiotic relationship. So you have a photosynthetic part of the relationship and an animal part of the relationship. So that's why corals are really unique to work with in the lab, because they allow you to look at effects on 2 different types of organisms at the same time and how that relationship is changed by the exposure to whatever it is that you're using. So we're able to examine the photosynthetic efficiency of the symbiont zooxanthellae at the same time using pulse amplitude modulated fluorometry, which essentially looks at the efficiency of photosystem 2. We also look at growth rate of the coral. This is a little more applicable to long-term exposures, but when we run these exposures, we also, any corals that are surviving at the end, we take those and we monitor their recovery over time. So it allows us to assess their recovery after the exposure. So this is what the corals look like after 96 hours of exposure to different concentrations of ThickSlick. So across the top, we have stag-horn coral, Cropos cervicornis, and across the bottom, Phrygis divericata, with increasing concentration from left to right. So the control was the first set of images, and then increasing concentrations from there. I don't have the highest concentration we tested shown because after 96 hours, there was just 100% mortality. So what do we see? So the lower concentrations, we tend to see that primary stress response of polyp retraction in these corals. As you increase the concentration, you see a lot of mucus production, and eventually you see tissue thinning, and that eventually leads to mortality. So if you take all of this data and put it together, I've just generated some threshold values for you here. So NOEC, which is the no observed effect concentration, that's the highest concentration that's not statistically different from the response seen in control. The LOEC, which is the lowest observed effect concentration, that's the lowest concentration that is statistically different from the control. And the 96-hour threshold. So either mortality, which is the top row there, which would be the LC50, physical changes, the polyp retraction, that sort of response that we saw, which is the EC50, and then across the bottom, the photosynthetic efficiency of the symbiotic flagellate. So the take-home message here is that all of these thresholds were greater than the 10 milligram per liter threshold for toxicity, which is the UK regulation as well as the US regulation. Interestingly, and I don't know if this was an endpoint that was looked at in some of the experiments that were done with single-celled algae and other more standard species, but we did see some sort of impact on photosystem 2. So that's something that, and a lot of our surviving corals were bleached, and we're still monitoring their recovery. This Friday is the 4-week recovery date for Phrygis divericata, so we'll be able to flesh out some more of that information. So that's all I have. Thank you very much. Special thanks to the Murder Working Group for including me to my 2 graduate students for helping with this research, and I'd be happy to take my questions.